Welcome to In 5 Minutes. In this video clip, we will discuss an important topic of multiplexing. There are two types of multiplexing systems. They are called frequency division multiplexing (FDM) and time division multiplexing (TDM). We will first try to understand what is multiplexing and then we will discuss both the types. Multiplexing is a technique in which we transmit number of independent signals in the form of one composite signal which is suitable for transmission over a common communication channel. So in simple words, we have one single communication channel and we want to transmit multiple signals over that one common channel. Now if you have got only one communication channel, then you can only transmit one signal through that particular channel, and hence if you want to transmit, let's say, 10 modulating signals or information signals, then you will have to somehow combine those 10 signals into one composite signal and transmit that one composite signal through the communication channel. On the receiver side, you will receive this composite signal which consists of multiple information signals, let's say 10 information signals for example, and very carefully you'll have to separate out the 10 information signals from each other. So if I give you an overview of a multiplexing system, even before we talk about FDM or TDM, you can have, let's say for example, 10 transmitters. Every transmitter will transmit one signal, and likewise we can have 10 different signals to be transmitted. We will combine these 10 signals into one composite signal. It will be transmitted through a common communication channel. On the receiver side, we somehow separate out these 10 signals from each other and we give each information signal to one receiver. So there will be 10 receivers which will be receiving those 10 information signals. The advantage of multiplexing will be that we require single communication channel for the transmission. I can achieve transmission of multiple signals through same communication channel. Now, why we do multiplexing, and let's try to understand multiplexing in detail. So I'll start with an example. Let us take a communication channel that is available to us. Let's say for example, this is a frequency axis on which there is a communication channel which has got bandwidth from 1 megahertz to 2 megahertz. So right now we are having a channel with bandwidth of 1 megahertz, and the channel starts at 1 megahertz and goes up to 2 megahertz on frequency scale. And let's say my aim is to transmit 10 information signals such that the bandwidth of each and every signal is, let's say for example, 10 kilohertz. So 10 signals each of bandwidth 10 kilohertz is what we want to transmit. Now if you make a simple calculation, you can see that 10 signals each of bandwidth 10 kilohertz, we require total bandwidth for transmission that will be 10. Let's say for example, we have 10 signals to be transmitted, 10 signals, and each signal has bandwidth of, let's say for example, 100 kilohertz. Now let's say how this can be done. If I want to transmit 10 signals each of bandwidth 100 kilohertz, one option is that I require 10 different channels, 10 channels such that each channel will be of bandwidth equal to 100 kilohertz. Now in such a case, I can use every channel for the transmission of one signal. The second possibility, the second approach for the transmission of this 10 signals will be, I can have one channel. Now see, what will be the total bandwidth required for the transmission? 10 signals each of bandwidth 100 kilohertz. So the total bandwidth required for transmission will be 10 into 100k, which will be 1 megahertz. So instead of having 10 channels each of bandwidth 100k individually, I can also have one channel with bandwidth of total, let's say, 1 megahertz. Even if I have one channel with bandwidth of 1 megahertz, I can transmit 10 signals each of bandwidth 100 kilohertz. Let's see how this can be done with the help of multiplexing. And to be precise, we will now talk about the very first type of multiplexing, which is called frequency division multiplexing (FDM).